What is force and motion in magnetic field? The force acting on a conductor of length L carrying a current I situated in a magnetic field B is given by Fm equals to BIL. The direction of force is perpendicular to the plane consisting of the components of B and I that are mutually perpendicular and is directed along the advance of a right-hand screw. If an electron takes t seconds to travel a distance of L meters in the conductor, the total number of electrons passing through any cross-section of conductor in unit time is nt, where n is the total number of electrons contained in the conductor. Thus, the total charge per second crossing any point is I is equal to nq by t. Fm equals to BIL equals to BNQL by t. Direction of force on a particle in magnetic field. Fm equals to QNBV, where V is the drift velocity and the force per electron is Fm equals to QBV. If the particle is a positive ion, the directions of current and velocity are same. If the particle is an electron, the direction of the current is opposite to that of the drift velocity. Motions in a magnetic field. Consider an electron to be placed in the region of the magnetic field. If the particle is at rest, Fm is equal to 0 and the particle remains at rest. If the initial velocity of the particle is along the lines of the magnetic flux, there is no force on the particle. Hence, a particle whose initial velocity has no component normal to a uniform magnetic field will continue to move with constant speed along the lines of flux. Now, assume that an electron moving with a speed Vo enters a constant uniform magnetic field normally. Since the force Fm is perpendicular to V and so to the motion at every instant, no work is done on the electron. That is, the kinetic energy is not increased. Since V and B are both constant in magnitude, Fm is constant in magnitude and perpendicular to the direction of motion of the particle. This type of force results in motion in a circular path with constant speed. The force remains constant in magnitude and is always directed toward the center of the circle and so is normal to the motion. A particle moving in a circular path with constant speed v has an acceleration toward the center of the circle of magnitude v to power 2 by r, where r is the radius of the path. Thus, mv square by r equals to ebv. R is equal to mv by eb. Angular velocity can be given as omega equals to v by r equals to eb by m. The period, time in seconds, for one complete revolution can be derived to be t equals to 2 pi by omega equals to 2 pi m by eb. For an electron, it is t equals to 3.57 into 10 power minus 11 by b. It can be observed that the radius of the path is directly proportional to the speed of the particle. Further, the period and the angular velocity are independent of speed or radius. That is, the faster moving particles will traverse larger circles in the same time that a slower particle moves in its smaller circle.